Alright, so here's another all-encompassing example for a weak base. So we've got a half molar solution of the weak base methylamine. What's the pH of the solution? Now, as I have counseled before, always start with the equilibrium. So this is going to be CH2NH2. This is a neutral molecule, it's aqueous. It's going to react with liquid water and form, again, so this is a good practice for predicting products. So what's going to happen is that the base is going to pick up a proton, and I'm going to call it CH2NH3 plus, because the proton attaches to the nitrogen atom. And what's left of the water molecule is simply a hydroxide after it's done the proton. And then we can construct our ice table. Again, I have to deal with the water. We know that this was originally 1.5 molar. We initially have none of this stuff, which means you can expect some formation of it. And from the stoichiometry, you will lose that same amount of methylamine concentration. And this gives us 1.5 minus x molar of the methylamine when equilibrium is reached, x molar methyl ammonium, and x molar hydroxide. Now I'm going to abbreviate this stuff Ma, and this is HMA plus. And let's just write the equilibrium constant expression Kb. That's going to be equal to the HMA plus times the hydroxide concentration divided by the methylamine concentration. Symbolically, that's going to be equal to x squared over 1.5 minus x. Now, so the Kb here was 4 in the 4 times 10 to the negative 4 range. That's a little larger than the cutoff that I talked about, but it might be worth it just to give it a shot because this is a fairly high initial concentration. So maybe we will just think that this is approximately equal to x squared over 1.5, and that is equal to 4.38 times 10 to the negative 4. Now doing the algebra, we've got x squared is equal to 6.57 times 10 to the negative 4, and that x is equal to 0.0256. Now, right off the bat, let's get a different color for this. Let's see if our approximation is okay. So here we've got 1.5 minus 0.0256. And if we are going with the sig fig rules, we should answer this to 1 decimal point, and that actually doesn't change. That actually is still 1.5. It would be like 1.48 some odd, so that's okay. So this approximation was legit, so we can go with these values. So the equilibrium concentration of hydroxide and of the methylamine was 0.0256 molar, and this is about 1.5 molar. Now, I asked you for the pH. Recall that pH is equal to the negative base 10 log of the hydronium concentration. We don't know that, or do we? You may recall from a few slides back, maybe I'll switch to red for this, that the concentrations of hydroxide and hydronium for any one aqueous solution are related. And the relationship was that the product of the hydronium concentration and the hydroxide concentration was equal to Kw, or 1 times 10 to the negative 14. which means that in this case our hydronium concentration is equal to 1 times 10 to the negative 14th divided by the hydroxide concentration, which was 0.0256, and that ends up being 2 sig figs, 3.9 times 10 to the minus 13 molar, which returns a pH of about 12.41. So again, if you can follow along with this one, you should be able to handle anything I throw at you on the exam.